Students, in this video I will demonstrate the third experiment of part A. So the experiment is using a 741 op-amp, design a window comparator for any given UTP and LTP, and we need to simulate the same. The simulation part will be explained in the next video. So in this video I will show you the demonstration how to make the connection for this experiment. Okay, so this is the circuit diagram. So for window comparator we need two op-amps. So usually whatever the inputs we give for an op-amp, it will compare the two inputs. So that's the overall operation of a window comparator. So here there are two op-amps. A1 is the first op-amp and A2 is the second op-amp. The IC number for this op-amp is 741. We need two op-amps, and then we need two diode of 1 and 4007. We need two diodes. So that these diodes have a polarity, positive and negative terminals. It has two terminals, one is positive, another one is negative. Then we need one resistor of 1 kilo ohm. Then we need a DC regulated power supply to supply the plus volts and minus 12 volts to both of the op-amps. Then we need a signal generator, and then we need CRO to get the output, and also we need the reference, also we need the regulated power supply to give the UTP and LTP values, to give an UTP value and LTP value as a reference voltage. So here what I will be doing is I will connect two ICs onto the middle of the breadboard. After connecting two ICs, so the pin number, the second pin of the first IC and the third pin of the second IC should be shorted. So for that what you need to do is you need to take one wire, one end should be connected to the second pin of first op-amp, and the another terminal of that wire should be connected to the third pin of the second op-amp, and we need to connect a signal generator. So the output of the signal generator should be connected either to the second pin of first op-amp or to the third pin of second op-amp, because both are shorted, right? Both the pins are shorted. So the output of the signal generator can be connected to the second pin or to the third pin, and the ground. So again we will be having a ground pin on the signal generator that will be connected to the ground pin in a breadboard. So after that we need to consider the DC regulated power supply to give the reference voltage, that is LTP and UTP. So the positive terminal should be connected to the third pin of first op-amp, and the negative should be grounded. Moving on to the second, the UTP value, again in regulated DC power supply, the positive end of UTP value should be connected to the second pin of second IC or second op-amp, and the negative terminal should be grounded. After that we need to take two diodes. Positive end of the diode is connected to the the sixth pin, negative end is connected to the junction. Okay, then we need to take the second diode. The positive end of that diode is connected to the sixth pin of the second IC, negative end is connected to the junction, and from the junction we have one resistor. The one end of the resistor is connected to the junction, another end should be connected to ground. So next, moving on to the CRO connection. As you all know, the CRO has two channels. Channel 1 positive is connected to the sixth pin of first op-amp, and channel 1 negative should be grounded. Moving on to the channel 2 positive should be connected to the signal generator, which means that it can be connected to the second pin or to the third pin of a second IC, and the negative terminal of the signal generator should be grounded. Okay, so this is the breadboard which I am taking here. I need two 741 op-amps. So I will fix these two op-amps on the middle of the breadboard like this. So after connecting this, I will take two diodes. See here, diode has a positive terminal and it has a negative terminal. The positive terminal of the first diode should be connected to the sixth pin of first IC, and negative end should be connected to the junction. So here I will select one series on the column 3. So I will make that as a junction. So another end of this diode is connected to the new series like this. So I have considered this series as a junction in the circuit. Now I will take up the second diode, where here the positive terminal is connected to the 6th pin of a second IC and negative terminal is connected to the junction. Negative terminal is connected to the junction. So this is the junction series which I have considered on the breadboard, and for this, from the same junction I need to connect the resistor, where resistor doesn't have any polarity. One end is connected to the junction, another end is connected to the ground. See here, the column 4, the last column is considered as the ground connection. So here we need to connect the pins one below the other. So whereas in the column 2 and 3, here we need to consider the pins in a series, which means that we need to make the connection by considering the one pin after the another pin. So okay, so this is how we need to make the connection. So moving on to the circuit connection, here I have already made the circuit connection. See here, this is the signal generator. The output of the signal generator is connected to the second pin of first op-amp. The ground connection, the negative terminal of the signal generator is connected to the ground pin. So the ground column, here column 4 is considered as the ground connection. So the negative terminal from the signal generator is connected to the ground pin. Okay, so next, to give UTP and LTP values, we need a regulated power supply. So the below one is the regulated power supply. So this is the UTP, this is the LTP, and this is the UTP. So moving on to the LTP, here we will be having two knobs or two terminals. One is a positive, another one is a negative. So the positive terminal of LTP should be connected to the third pin of first IC. See here, I have taken one wire. One end of this wire is connected to the positive terminal of LTP. Another end is connected to the third pin of the first IC. And the negative terminal from the LTP is connected to the ground connection. Moving on to the UTP. So this is the UTP connection. Again in UTP there are two terminals. The positive end is connected to the second pin of a second op-amp. See here, I have taken one wire. One end of this wire is connected to the positive terminal of the UTP. Another end is connected to the second pin of a second op-amp. Next, we need an DC power supply to give plus volts and minus volts. So in both the op-amps, plus 12 volts should be given to the 7th pin and minus 12 volts should be given to the 4th pin. See here, we have a plus 12 volts and minus 12 volts. So I have connected the positive to a plus 12 volts is connected to the 7th pin of both the op-amps. Minus 12 volts is connected to the 4th pin of both the op-amps, and we have connected the ground connection, where I have taken one wire. One end is connected to the COM, that is ground. Another end is connected to the 4th column of a breadboard. So this entire column is a ground connection. I have considered the entire column as a ground connection on the breadboard. So after that, so these are the two channels of the CRO. Channel 1 positive is connected to the 6th pin of the first op-amp. See here, this is the first op-amp. What I have done is the positive terminal of the channel 1 is connected to the 6th pin. Negative terminal of the channel 1 is grounded, which means that is connected to the 4th column in the breadboard. Moving on to the channel 2. So in channel 2 I need to get the sine wave. So from the signal generator, so channel 2 positive is connected to the signal generator, or it can also be connected to the second or third pin of an op-amp. Okay, which means that on the circuit what I have done is I have shorted the second pin of the first op-amp and the third pin of the second op-amp. So if I want to get the sine wave, or if I want to get the waveform from the signal generator, so if I want to get the waveform from the signal generator, that is the sine waveform from the signal generator, the positive terminal should be connected to the second pin of the first op amp or to the third pin of the second op amp, and negative should be grounded. That's what I have done here. The positive, the channel 2 positive terminal is connected to the second pin of the first op amp, and negative terminal of channel 2 is connected to the ground, which means that I have connected the other end to the fourth column in the breadboard. So after doing this connection, this is the output. So from channel 1, so this is the output of channel 1, which means that this is the output of the window comparator. So it is having two states, high state and a low state. So this waveform has been generated from the signal generator, that is sine wave. So sine wave is the wave which is generated from the signal generator. So if I turn the switch to the dual mode, so I will get both of the waveform. The first waveform is an output from the window comparator, and the second waveform is the output of the signal generator. So from the signal generator, the output of the window comparator is having two states, high state and low state. So comparator, there will be two op amps. The first op amp is called as A1, the second op amp is called as A2. So here the input signal is generated from the signal generator, and whatever the waveform which we get from the signal generator, that will be connected to the input of both the op amps, and that signal then that signal will be compared, that input will be compared with the LTP value as well as with the UTP value. So whichever is greater, that will be the output of window comparator. Okay, so then we have two diodes here. So the first diode is connected, the positive terminal of the diode is connected to the sixth pin of first op amp, and another diode is used, and the positive terminal of the second diode is connected to the output terminal, that is nothing but the sixth pin of the second op amp, and the negative terminal of both the diodes are connected to a junction, and from that junction one resistor is connected, and that resistor is called as the load resistor. The value of this RL, that is the load resistor, is 1 kilo ohm, which we are using in this circuit. Then one end of that resistor is connected to the junction, another end is connected to the ground. Okay, so then we will be using LTP and UTP values to compare the input signal which is generated from the signal generator. LTP means lower trigger point, UTP means upper trigger point. So now we will construct the same circuit on the simulation tool, and we will verify the output, whether we are getting the correct output or not. So now open electronic workbench application. Okay, so this is the electronic workbench application. Now the thing is, we need to drag and drop all the components which we need to construct window comparator. So main component which is needed to construct the window comparator is op amp, right? So go to analog ICs, click on the second op amp, where this is the 5 terminal op amp. This is the 5 terminal op amp. So we need 2 op amps. So drag and drop 2 op amps. Next, we need a signal generator. Go to sources and click on the fourth component. Go to sources and click on the fourth component. So this is the signal generator, where it generates a sine wave. So the positive terminal of the signal generator, wait a minute. So here the non-inverting terminal of the first op amp and inverting terminal of the second op amp should be shorted. Okay. Next, the positive terminal of the signal generator should be connected to the one of the input of the op amp, that is either to the non-inverting terminal of the first op amp or to the inverting terminal of the second op amp, because non-inverting terminal of the first op amp and inverting terminal of the second op amp is shorted as per the circuit. See here in this circuit, in the non-inverting terminal and inverting terminal of both the op amps are shorted, and the input voltage, that is V,
VI from the signal generator, the positive terminal of the VI from the signal generator is connected to this shorted circuit. Okay, the negative part should be grounded. The negative terminal should be grounded like this. Yeah. Now we need to provide UTP and LTP values. So to provide UTP and LTP values, drag and drop the power source and rotate it. See here, in the first op amp, we have one terminal that is nothing but the inverting terminal. So inverting terminal, the sign is negative. So the next source of the power supply should be connected to this point. And positive should be grounded. So this is how we need to make the LTP connection. Positive should be grounded and negative should be connected to the inverting terminal of the first op amp. Next, we need to connect UTP value. So just drag and drop another power source. Rotate it. Yeah, here the positive terminal of the power source should be connected to non-inverting terminal of the second op amp, and negative terminal of the power source, that is nothing but the negative terminal of the UTP, should be grounded like this. Okay, so next thing is we need to provide the plus 12 VCC and minus 12 VCC for both the op amp. So what I will be doing is I will take 4 power sources. I will rotate this. Fine. See here, this is the 7th pin. This is the 7th pin where the plus VCC is from the 7th pin of the op amp. It should be connected to the positive terminal. It should be connected to the positive terminal of the power source, and the negative terminal should be grounded. The negative terminal of the terminal of that power source should be grounded like this. Okay, next, moving on to the 4th pin of the first op amp, the negative minus VCC should be connected to minus 12 volts and positive should be grounded. The positive should be grounded. I will connect to ground connection. Next, moving on to the second op amp, the positive terminal of the op amp should be connected to the positive terminal of the power source and to provide a plus 12 volts, and negative from negative terminal of the that is minus VCC should be connected to minus 12 volts. That is nothing but the negative terminal of the power source, and the negative. So in this power source, the negative terminal should be grounded, and in the second power source, positive terminal of the power source should be grounded like this. Okay, so next, what else we have in the circuit? We have 2 diodes, right? The positive terminal of the diode is connected to the output of both the op amps, and the negative terminal should be connected as a junction. Now we will do that connection. So go to diodes, click on the first component, drag and drop it. So connect the positive terminal of the diode to the output of an op amp. So we need another diode where positive terminal is connected to the output of the second op amp, and negative terminal of both the op amp should be shorted. So like this, the negative terminal of both the diodes should be shorted, and this will make a junction. So in this junction, we need to connect one resistor. So go to sources, go to basics, click on the second component and drag and drop the resistor, rotate it. So one end of the resistor is connected to the junction, another end should be grounded. So go to sources, drag and drop the ground connection. So connect other end of the resistor to the ground. So we are done with this circuit. After doing this, we need to see the output, right? So to see the output, we need a CRO, cathode ray oscilloscope. Go to instruments, drag and drop the third component. Drag and drop the third component. So here, this is the CRO. Actually, this is the CRO. At the bottom, there are 2 pins. the first pin is a channel 1 positive, the second pin is a channel 2 positive. Moving on to the right side, there are two pins. The first pin is a channel 1 negative and the second pin is a channel 2 negative. So both the pins on the right hand side should be grounded. So what I will do is I will connect the first pin to the ground and I will connect the other pin which is on the right side of the CRO. I will connect that to the ground. Next, channel 1 positive, that's the first pin on the CRO that is connected to the output of the first op amp. Or also you can connect that pin to the output of the second op amp. So either you should connect the channel 1 positive to the output of the first op amp, or you can also connect the channel 1 positive terminal to the output of the second op amp. So thus from this channel 1 we will get the output of a window comparator. It will be in rectangular wave. So we will get a rectangular waveform from this output. Then we need to get the input waveform, right? So here the input is applied from the signal generator. So if we want to get the input waveform, so here the signal generator which I have chosen is the sine wave generator. So the input waveform will be sine wave and the output of the window comparator will be a rectangular waveform. So to get the input waveform, what I will do is I will connect channel 2 positive to the positive terminal of the input, a positive terminal of the signal generator. Now we are done with the connection and we need to make some, we need to change some values here. Click on this signal generator, right click. So click on the signal generator, right click, select component properties. Here voltage is 1. So initially we have voltage as 120. Change this to 10 volts. Change this to 10 volts and click on OK. So other change what we need to do is we need to select the appropriate diode here. So click on the diode. Click on the diode, select that diode, right click, select component properties. Here go to models, then select general 2, then scroll down. You need to select D1N4007. Here we have a D1N4007. Click on OK. Then select the second diode, right click, select component properties, go to models, select general 2 and select D1N4007. Click on OK. So these are the things which we need to do. Then we need to see the output waveform. So to see the output waveform, double click on the CRO. So we will get an output screen, that is the oscilloscope screen. Next, on the top right corner, there is a on and off button of the CRO. Just switch on the CRO and switch it off. So here you need to change the time division to get the waveform. To get the correct waveform, you need to change the time division. Yeah, yes. So this is the output which we got. There are two waveforms in this. One is a rectangular waveform, another one is a sine waveform. Where rectangular waveform is the waveform which is obtained from the window comparator or from the channel 1, because channel 1 positive is connected to the output of the first op amp. From that only we have got the rectangular waveform. The second waveform is the sine waveform. So where this sine waveform, we got this sine waveform from the signal generator, from the input voltage, that is from the signal generator. So these are the two waveforms which you need to get in the window comparator, and this is the correct output of window comparator, which is constructed on the simulation tool. So if you have any doubts on this, you can get back to me. So download, you can easily download this application on the Google Chrome. Just type, or on any browser, just type electronic workbench. Download electronic workbench. Click on the click on the second link and download, and you can easily install this application. Once it is installed, go to search bar of your system, type electronic workbench and open the application, and just drag and drop all the components, drag and drop the components which is needed to construct the circuit, and after drag and dropping the components, you can make the connection. You can make the connection and the circuit can be verified from the CRO. So the output will be obtained from the CRO. So you can verify the circuit from the CRO whether you are getting the correct output or not. So to view the waveform correctly, you need to change the time division. So this is the time division. Here you need to increase or decrease the time division to get the correct waveform.